Welcome back to Pentagramprime. Today's episode will be determining the convergence or divergence, of course, of the summation from 1 to infinity of n times negative 3 to the n divided by 4 to the n minus 1. And we will be using the root test. What we're actually going to be determining today is the absolute convergence, or divergence, or convergence, conditional convergence. You'll see in a moment. Let's take a look at the root test. Oh, and before I forget, Calculus Early Transcendentals, 4th edition by James Stewart. Pulled this off of page 737. So the root test, shown on page 735, tells us that if we take the nth root of the absolute value of the term a sub n, and we take the limit of that as n goes to infinity, and it exists, and it's less than 1, then the series from 1 to infinity of a sub n is absolutely convergent, and therefore the series itself is also convergent. Likewise, if the series is has a value greater than 1, if the limit, aforementioned limit, has a value greater than 1, or if that limit ends up being equal to infinity, then the series a sub n from 1 to infinity is divergent. So in this case, we're going to take this term, n times negative 3 to the n divided by 4 to the n minus 1, and we're going to take the nth root and of the absolute value, and then we're going to take the limit of that as n goes to infinity. So here's the thing we have to work with, and we're going to focus in on the term for a moment. We'll come back to the limit shortly. So the first thing we're going to do is we're going to switch up the terms here. Put 1 over n into the into the superscript, and then we're going to start looking at what we can pull outside of the absolute value signs. In case you haven't noticed, n is, for our purposes, always positive, and so is the term 4 to the n minus 1. So we can pull those outside of here, keeping the exponent in mind, of course. And then we have to take a look at negative 3 to the n inside of the absolute value signs. And of course, we just drop the minus sign, and the absolute value becomes of negative 3 to the n to the 1 minus n, 1 divided by n, sorry. It all comes to 3 to the n over n, which of course those two n's are going to cancel out. Ta-da! And we can do the same thing in the denominator. And since we have 4 to the 1 and 3 to the 1, those are constants, and we can pull them off to the left-hand side. So our term is inside that limit. The aforementioned limit is 3/4 times n to the 1 over n divided by 4 to the negative 1 over n. And we could probably do something with that minus sign as well. So that means we can move it up to the numerator, because it was already at the denominator before. So this is the limit we're dealing with. N going to infinity of 3/4. I'm sorry I did not pull this on the outside of the limit earlier in my notes, but we're dealing with really the limit of n to the 1 divided by n times 4 to the 1 over n. So you need to figure out what the behavior of this thing and this thing is going to be. It helps that we can go ahead and turn n into e to the ln of n, and 4 into e to the ln of 4. So let's have a look-see. So we convert these terms into exponents. And then what we can do is we can combine this exponent with this exponent and this exponent with this exponent. If we look down at the bottom here, first of all, we're going to move that pesky 3 to the 4th off to the left-hand side like we should have earlier. And over here, we have a new set of exponents, ln divided by n, and we have ln of 4 also divided by n. And then from here, using the properties of limits, if these two are continuous functions, and they are for our purposes, then we can take the limit of a continuous function and bring it inside the argument of the function, in this case the exponent of e. So we bring the limits inside, and now we have two different limits we're dealing with. Limit of n to infinity of ln divided by n, and the limit as n goes to infinity of ln of 4 divided by n. I really hope it's obvious that this one goes to 0, but I will spell it out a little bit later just in case. But yeah, this one's going to go to 0 because ln of 4 is a constant, and dividing it by n as n goes to infinity is just pfft. So that one's going to disappear. This one's a little more interesting though. So let's have a look at it. So the limit of ln of n quantity divided by n as n goes to infinity can be evaluated using L'Hopital's rule. Hope you remember that one too if you're watching this. We're going to take the derivative with respect to n of both the top and the bottom, and let's see what we get. So we take the derivative of first derivative of ln of n with respect to n, and we get 1 over n. In the bottom we just have n. Derivative of that is equal to 1. So this limit ends up equaling limit of 1 over n once you do out the algebra, and there's just 1 on the bottom. And common sense tells you that this goes to 0. And then of course we have the other limit that we were talking about earlier. ln of 4 divided by n. Pull the 4 out, we get limit as n goes to infinity of 1 over n. That equals 0 as well. Moving on. We can see that both these exponents are now going to have zeros. Both these exponentials are now going to have zeros in their exponents. And hope this is obvious right here, but let's spell it out a little more. Scratch those, they both equal 1. And our limit is now equal to 3/4. So for the sum of n times negative 3 to the n divided by 4 to the n minus 1, summed from 1 to infinity, if we take the nth root of the nth term, the limit, and the limit of that as it goes to infinity, we find that the limit is equal to 3/4. 3/4, for those of you who are still in preschool, is equal to, it's not equal to, it's equal to 3/4. But it's less than 1. Actually, are they teaching inequalities in preschool? I'll have to talk to my, no, I'm not going to talk about family here, but yeah. They're, I really think they could put inequalities in preschool, because I've seen kids that age and they know when they're not getting the same amount of ice cream as their brother or sister, you know? Alright, off topic. Anyways, 3/4 is less than 1, and that means per the, what did I call that thing? Per the root test, the aforementioned summation is absolutely convergent. So, thanks for watching. This is Pentagramprime saying, teach math to your preschoolers.